Hello again. So today we're going to be talking a little bit more about polynomials, and this time we're going to be focusing on multiplication and division of polynomials. And before we get into the specifics of those operations, I'd like to review a couple of properties with you that are extremely important. So the first one I'd like to talk about is the associative property. And associative property just says that changing the groupings or the parentheses does not change the sum or the product. So here we're talking about, of course, addition and multiplication. This property does not apply to division or subtraction because it just doesn't work. Let's look at our example. So here we have the parenthesis you see around the 2 plus 1, so 3 plus 2 plus 1. And we're saying that that's equal to 3 plus 2 plus 1. You notice we didn't move the numbers around at all. We just simply moved the parentheses or the grouping. And of course, if we followed PEMDAS here, we would have 3 plus 3, which is 6. And of course, here we've got 5 plus 1, which is also 6. So we can see that did not changing those parentheses around did not change the sum at all. And we know, of course, that it also works with multiplication. So we know addition and multiplication. So we know that 3 times 5, of course, is 15. 15 times 2 is 30. And, of course, here we've got 6. So 6 times 5 is also 30. So pretty simple to see that this property works for both of those operations. All right, so next we're going to talk about commutative property. It's very similar to associative, except for this time we're saying that changing the order of the numbers does not change the sum or the product. So once again, we're talking about addition and multiplication. So we're talking about changing the add-ins in a sum and changing the factors in a product. Okay, we're saying that that doesn't change the final answer. So you guys can see in the first example, we've got 4 plus 3 plus 2 is equal to 2 plus 4 plus 3. I mean, we can change the order of those numbers or those add-ins any way that we choose to, and it will not change the answer here. So if we just went left to right, we can see this is 7 plus 2 is 9. And here we have 6 plus 3 is also 9. Let's move over and show that when we multiply, it's the same situation. Here we've got 12 times 2, 24, and here we've got 6 times 4, which of course is also 24. So those two properties are really important to know, and they'll come, of course, more and more into play as we move forward. The most important property here that I'd like you to really focus on is this distributive property. And distributive property really just means multiplication across addition and subtraction. So you can see here in the parenthesis, we have an addition sign. We have this little 3 out front, and it's actually just saying to take that 3, excuse me, and to multiply that 3 by this 3 and by this 6. Okay, so we've got 3 times 3, of course, is 9. 3 times 6 is 18, and we add those together, which is 27. Now, I want you guys to also take a look at my little note over here. I want you to only use it when you cannot simplify inside the parenthesis first. So if we go back to our original example, we could have simplified this to a 9, right? And it's so much faster to do that. So if you can simplify inside your parenthesis, meaning you have like terms that you can combine inside your parenthesis, please do that first. It really alleviates errors, especially when we start throwing a lot of negative signs in there. So you don't need to use distributive property for that one. However, for this second example, we do, because you notice inside we have 2 different types of terms. We have an x and we have a 5. Those are not like terms. So we have to use the distributive property in order to remove the parenthesis. So we're going to have a 3 times x and a 3 times 5, which is going to give us 3x plus 15. And you notice we can't combine these these terms here either. These are different type of terms. So we just leave it as is. But this property is huge, and it's going to come into play a lot, especially with the multiplication of polynomials that we're going to talk about now. All right, so let's get into some different types of multiplication of polynomials. One of the first ones here that we'll talk about is the monomial times the monomial. And if you guys remember from the previous video, a monomial is one term. So in this example, we've got one term here, 6x squared, times another monomial, one term, negative 5x squared. And when we have this scenario, all we're really doing is multiplying the coefficients and then multiplying the variables using the product rule. So you can see we took this 6 times the negative 5. That's going to give us our negative 30. And then over here, we've got our x squared times our x squared. And of course, the product rule tells us to add the exponents when we have the same basis. So that's where we get this x to the 4th. So we get a negative 30 x to the 4th. All right, so the second type here is a monomial times a polynomial. And when we have that, here we go using that distributive property that we just talked about. And what we're really saying is that this 9x cubed in our particular example has to be multiplied by everything inside that parenthesis. So it's got to be multiplied by the 3x squared, by the negative 2x, and by the 7. Okay, so now I showed that separately, showed all the steps separately. You do not need to do that step if you don't want to. If you find that you can, multiply that mentally and just jump right down to this last step here, that's totally fine. But I just kind of wanted to show you what we were really doing there. So we've got the 9x cubed times the 3x squared. Right, that's going to give us our 27x to the 5th when we use the product rule on our variables. And one thing I wanted to bring up too, you guys see that, so sometimes the signs can get a little messy here, especially if we were to just add between these. If I had instead said, okay, oops, that's not what I wanted to have there, right? So if let's say that I instead had a plus sign here instead of a minus sign, and then I kept this negative, with the negative, with the 2x. So in the end, I would have had plus a negative 18. And the thing is, I would have two signs there. I would try to, if I were you, just make your life a little simpler and just look at what the two signs are that you have. We notice here we have, of course, a positive 9x squared and a negative. So what I did is I just said, all right, well, that's going to give me a negative. So I'm just going to say that this is a subtraction. I'm pulling it out front of the multiplication that I'm doing, so that in the end I only have this one sign here and I don't have to deal with double signs. Okay, so try to practice that. I think it'll help. If you are struggling at all with signs and double signs, I think that might be one method that might work for you. And then, of course, we have the 9x cubed times the 7. And in the end, we have this nice polynomial. Now, I want you guys to notice here, it says combine like terms if needed. In this case, we don't have any like terms. We have x to the 5th, x is to the 4th, and x is cubed. So we don't have any like terms, so we can stop right there. All right, so next on our list is a binomial times a binomial. Okay, remember that binomials are two terms. Okay, so for example, here we have a 2x plus 3 and an x minus 4. Those are both binomials, and they're multiplied together. So basically, guys, what we're going to be doing with these, or we're going to use what's called the FOIL method. It's a way of distributing numbers. It's called the FOIL method that I'm sure you guys learned on NROC. FOIL just stands for first, inner, outer, last. And I think that they showed it this way as well on NROC. You guys might just come up with your own system. But basically, what I'm saying is that I have to, let me just kind of color code these differently. Basically, my job is to multiply this 2x by the x and by this -4. And then I'm also going to have to take the 3, of course, and I'm going to multiply that by the x and by the -4. So I'm going to have 4 terms when I'm done with that part. I know that in the end I'm going to have 4 products basically because I am multiplying 4 different times, right? And that's what FOIL means. First, inner, outer, and last. You've got to take that 2x, multiply by everything in the second parenthesis, and the 3, and multiply everything in the second parenthesis. So once again, I actually expanded that out. I wanted to show you, but you don't need to do this step. But we've got the 2x times the x is going to give us our 2x squared. Once again, I just took this negative sign here, or this minus sign here, and I just pulled it right out and set it right out front here. Okay, so I've got 2x times a 4 basically, which is going to give me my -8x minus 8x. And then we've got 3 times x, which is 3x, and I pulled that negative again out, so -3 times 4 is 12. And then this time we do have some like terms, so we need to combine them. You notice we have x's here, so I've got a -8x plus a 3x is going to give me that -5x in the middle. So you're always just going to look back at it, making sure that you have simplified just as far down as you can go and that there are no other like terms that need to be combined. All right, let's move on. So we've got other, what we just kind of call other products, varying scenarios with other situations of products. So basically, the idea is we want to use distributive property to multiply each term in the first parenthesis by each term in the second parenthesis. So it's kind of like foiling, but it just, we have to kind of go a step further because there are more than just the binomial times the binomial. So in essence, this 2x needs to be multiplied by 2x squared, by the 4x, and by the -3, and then this 2 needs to be multiplied by the same 3 terms. Okay, so we can see that in the end we're going to have 6 different products here after we do that multiplication, right? We've got 6 different things going on there. Once again, you don't need to do this step if you don't find it helpful. Okay, so then we're down here where we have combining like terms if necessary, and you can see when we look through this step right here, we do have some terms that need to be combined. We've got this 8x squared plus another 4x squared, which is going to give us the 12x squared. We also have x's, so we have a -6x plus an 8x, which of course is going to give us that 2x. So you can see we did some combining of like terms. The 4x cubed and the -6 at the end don't have any other like terms with that. So looking back at our final answer, we can see we have finally combined all terms together. All right, moving on. So we have a couple of special products that I wanted to just talk to you about a little bit before we move on to division. So the first one is called the square of a sum, and you can see basically this is a sum, right? It's an addition sign there in the middle, so a plus b, and we have that quantity squared, and we want to make sure that we recognize that this is just that literally the base. This is an exponent, basically an exponent problem here, right? The base is a plus b, quantity a plus b. So remember that the exponent always tells us how many times to multiply the base by itself. So that's why we have a plus b times a plus b. a very common mistake is for students to look at this even when they know, even when we've talked about it and they know. Sometimes, you're on a test or a benchmark and you kind of start to panic a little, and what they do is they would say that is a squared plus b squared, right? And that's not true. We don't actually distribute this exponent across that addition. We can't do that. Okay, so this is definitely not true. Be careful of that. Okay, and we have a similar situation with the square of a difference. Of course, difference means subtraction. So quantity a minus b squared is going to just give us those two bases of quantity a minus b, and we're going to multiply that by itself. And then we have a product of a sum and difference. Okay, so we've got a plus b times a minus b. And the cool thing about this is that the middle term will disappear after you FOIL that. Let's actually try that. Okay, so let's FOIL this baby. A times a, going to give us a squared. A times a negative b, it's going to be a minus ab. Now we're going to take this b and multiply that, so b times a. Now here, the thing is, guys, is that we would like to use our commutative property here. I could have listed plus ba, but if I do that, do you see that the ba and the ab kind of then look like different terms? But remembering the whole idea of commutative property that we just talked about, remember that commutative property states that a times b is the same as b times a, right? So that's kind of important to remember, and therefore we can switch that a and b around, and then what we have, we can see very clearly, are these two like terms here. Okay, and then finally we have this b, positive b times the negative b, which is going to give us negative b squared. And what we see is if we have a negative ab plus an ab, those middle terms disappear, leaving a squared minus b squared. So another important idea here, guys, is that we are learning these here in Unit 11. We're learning how we would expand. So in Unit 11, what we're really doing is we're taking these initial terms, basically, and we're expanding them. We're learning how do we distribute, how do we FOIL them, how do we expand them out to something bigger. In Unit 12, we're just going to be going the opposite direction. So in Unit 12, this is going to be a special case called a difference of squares. And interestingly enough, when we're done, and our job in Unit 12 will be to factor this baby, meaning find the two factors that when multiplied together come up with this, and we are going to be factoring back down to the quantity a plus b times quantity a minus b. So interestingly enough, Units 11 and 12 are kind of the opposites of each other. They go together, and we need to really understand Unit 11 before we can move on and understand how we factor in Unit 12. All right, let's move on with some division of polynomials. And guys, division of polynomials is very straightforward, at least with what we're covering in this class. We are dividing by a monomial in this class. You can actually, of course, have a binomial in the denominator, a polynomial in the denominator, and that's actually fun, but a little bit more complicated. So in this particular class, we're just sticking with this idea of having a monomial in the denominator. One of the things I'd really like to point out to you guys is, let me just get rid of some of this so we can make a little room and have it not be so messy, is that when we're dividing polynomials, I'd like you guys to think of your addition and subtraction of fraction rules, and we're just going to be thinking of that in reverse. So If we were initially given a problem like this here, in our unit 2, if any of you did the review unit in our fractions, we know that we have to have a common denominator in order to add fractions, right? Well, this luckily has a common denominator, and so we would have gone this direction because we know that the rule states that we add the numerator, all the numerators, and we keep the denominator the same. So we would have ended up with a plus b plus c over d, right? Well, we can see that in Unit 11, we're kind of going the other direction. If we take a peek at our example here, we have 3 terms on the top, and they're all being divided by a 3x or a monomial. Well, we need to kind of go this direction. We need to think about expanding that. And the main idea here, the key idea, is that this 3x right here is not just being divided by one of these terms up top. It has to be divided, it's being divided by all of those, right? So we've got the x to the 4th divided by 3x, 15x cubed divided by 3x, and 6x squared divided by 3x. Now, why is that important? It's really important, actually, because we can think about this. If we didn't, I guess I'll say if we didn't think about this, we might look at that and go, oh, yeah, this x is going to go out with one of those, going to leave that, the 3 is going to go out, and that's going to leave a -2, and I'm done, woohoo, right? But I'm not. I have to consider the fact that the 3x is important to all 3 of those terms in the numerator. All right, guys, so our job is to very simply simplify the coefficients. Okay, so if we can simplify the coefficients, we will. It looks like in this case we can, and in this case we can, so that's good. And we are going to use the quotient rule on the variables. And you don't actually have to list out, remembering that the quotient rule is subtracting those exponents. That's fine. You don't actually have to list all of that out separately. Let me show you what I mean by that. Let's just take this very first term here. We've got x to the 4th over 3x. Well, we can't simplify the coefficients, so I'm going to list this 3 here in the denominator. And if we wrote out the quotient rule, of course, we would have our x to the, I'm going to write that up here, x to the 4 minus 1, right? There's a 1 here, which is x cubed. You can do that if you want. Of course, you can see that's what we set right here. The other thing is just to mentally think about this. And you don't need to draw this out. I'm just doing this to illustrate what I am thinking in my head. Right? I've got 4 x's on top, and I have 1 on the bottom. Of course, that 1 on the bottom is going to be canceled, and there will be 3 remaining on top. In the end, you don't even need to write anything. You can just jump right from this step here right down to here. All right, and we know in this second term, 15 divided by 3, whoopsie, what happened to my 5? It's disappeared. I'm going to have to put that guy in there. This is a 5. Yes, 15 divided by 3 is definitely 5. We've got the 5, and then we've got 3 x's on top, 1 on the bottom. Of course, that's going to cancel with one of those, leaving 2. So we've got 5x squared as our second term. And on our third term, we have a -6 over 3, which is a -2. And I've got, if you like the quotient rule, we would do this and come up with an x, or we'd say, yep, this goes out with one of those, leaving just an x. And of course, if we look back at this, we can see that none of these terms are the same. We don't need to do any sort of combining like terms or anything. The other way that, I guess one other thing I'd like to throw out there is this first term could also be written, if we choose to, as 1/3 x cubed plus 5x squared minus 2x. So if you prefer, you can write it that way. Doesn't really matter. They're both the same thing. Okay, guys, I want to just cover one of the application problems. This is one on your worksheet. I want to remind you too that when we're dealing with polynomials and on the application problems, we're looking for a polynomial to represent the situation. Okay, we're going to seldom come up with just one number as our answer. Sometimes we will. It just depends on the actual application problem. But really, in the end, what our job is to look for a polynomial. That's what we're practicing. That's what we're being assessed on. Okay, let's look at our example. All right, so we have an irregularly shaped lot is made up of two rectangular sections. Given the dimensions. Okay, I cannot read. Let me start over. An irregularly shaped lot is made up of two rectangular sections. Given the dimensions below, write a polynomial that represents how many square feet make up the lot. All right. So, yeah, a couple things we need to be thinking about. We're looking at area, right? So let's remind ourselves a couple of knowns, a couple of known things. We definitely need to know how to find the area. Well, do we have a formula for the area of this irregular shape? No, we don't. This is quite an interesting shape. We don't have anything that we know of as a formula. So what we really need to do is think about possibly just sectioning this off into shapes that we do know. So here we have two rectangles. We definitely know a formula for finding the area of a rectangle. We know that area is equal to length times width for a rectangle. So if we kind of think in those terms, it's going to be a lot easier to answer this problem. Okay, so one thing that we could also do is just name these. This could be my small rectangle, which I'll call A. My large rectangle I can call B. Okay. Let's actually write down those as a known. So my area of A, if we know that it's length times width, right? Here would be my length. Let's do that. Here would be my width. Okay, so that's going to be x plus 2 times x plus 1. And if we were to take a look then at our rectangle B and try to figure out the length and width there, well, kind of looks like this up here would be my length, right? And this would be my width. Now we can double check that. We have this 4x plus 4 feet down here. Well, we can double check that. Is 3x plus 2 plus another x plus 2 equal to 4x plus 4? And it sure is. So we know that we're taking the right dimensions there when we're writing these down as our given information. Okay. So let's go ahead back here to our length times our width. Looks like it's going to be 3x plus 2 times 2x plus 3, and I should be very careful here because we have area measurements, so this is going to be feet squared, both of these. All right, so the reason that we write down the known information, of course, is because we want to know what to use when we're setting up our equation or our expression, in this case for the polynomial. All right, so we know that the area of the whole lot, which is basically what they're asking for here, a polynomial that represents how many square feet make up the lot. Okay, so that's going to be equal, of course, to both of the area of both of our rectangles. So we're going to have the area of A plus the area of B. All right, so let's come down here and start some work here. So area of A we have listed up here. We've got x plus 2 times x plus 1. Oopsie. There we go. And we're going to actually have to multiply that, or not multiply, sorry, add that to our area of B, which is going to be our 3x plus 2 times our 2x plus 3. I'm going to keep that separate, and I want to make sure that I'm putting on those brackets because I can see that I have binomials times binomials. And as we spoke of before, up above, we know that we have to FOIL these. So we want to keep them separate and do that work before we combine everything. And we know, I'm going to put this up here. I don't often like to put my units in when I'm doing the actual math. I think they get in the way for me. But I'm going to just note them there just so I don't forget them. Okay. Out of here. So we know we have to do some FOILing here. So we're going to do our x times both of the terms in that second parenthesis. So that's going to give us an x squared plus x. And then the 2 will be multiplied by both terms. So plus 2x plus 2. Okay, and I'm going to put my addition sign, and we're going to do the same thing with the second parenthesis. So we've got 3x times 2x is going to give us 6x squared. 3x times 3 is going to be 9x. 2 times 2x will give us 4x. And 2 times 3 can be plus 6. So area is going to be all of this feet squared. All right, so I got a lot of stuff going on here, and I can see that I have terms that I should be combining. So whether you guys want to stack these, whether you want to just box and circle, I'm just going to highlight just because it's a little bit easier when I'm using my iPad here. Okay, I've got some squares here, and looks like I've got x's here, 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 and here. And then I got some numbers, and I'll just leave those without some highlighting. So we've got x squared, so 1x squared basically plus 6x squared. That is going to give me 7x squared. And I've got 3 x's over here, plus 9 is 12, plus another 4 is 16 of them, so plus 16x. And then I've got a 2 plus a 6, which is going to give me 8. And I want to be careful to put that parenthesis on there, because if I don't, it's just going to look like 8 feet squared. But in fact, it's this whole polynomial feet squared. So the area of our lot is going to be quantity 7x squared plus 16x plus 8 feet squared. Okay, guys, so just practice these, and let me know if you have any questions. Alrighty, we'll see you soon.